Decorator pattern is one of my favorite patterns. The first time I learned about it, I was like, wow, that's pretty cool. We use this pattern to add additional behavior to an object. Here's a real example. Let's imagine you just got hired in a startup company that is going to sell cloud hosting services. Your job is to implement a class for storing data in the cloud. So, in our project, let's add a new package called Decorator. In this package, we add a class called Cloud Stream. With this class, we're going to read or write data to the cloud. So let's add a method called write, which takes a string called data. Now, we don't want to worry about all the complexity of storing data in the cloud. So instead, let's print storing plus data. Now, let's say tomorrow your manager comes to you and says, in certain situations, we need to encrypt data before storing it in the cloud. For example, when we're dealing with people's credit card, we don't want to store them in plain text, so we should encrypt them. Now, we don't want to modify this class because we're not going to encrypt everything that we're going to store in the cloud. We need encryption only in certain places. So how can we solve this problem? Well, we can create a new class called encrypted cloud stream that extends this cloud stream. Before writing the data, we're going to encrypt it. Let me show you. So let's add a new class called encrypted cloud stream. This class should extend our cloud stream class. Now we're going to override or change the implementation of this write method. So here we type write and press enter. This adds the override annotation. So with this, we can change or override the implementation of the write method. So before calling the write method of our base class, we're going to encrypt data. So let's imagine we have a method here, a private method called encrypt that takes some data, encrypts it, and returns it. So for simplicity, let's just return some magic string like this. Now, in this write method, before we call the write method of the base class, we're going to encrypt our data. So encrypt data, store it in a variable called encrypted, and then we pass that over here. Pretty straightforward. So let's test our implementation up to this point. We go to our main method. We create a cloud stream, new cloud stream. Now we call cloud stream dot write. Here is some data. Now, when we run this program, this data is going to be stored in plain text in the cloud. There you go. However, if we change this to encrypted cloud stream, our data is going to get encrypted before it's stored in the cloud. Beautiful. Now, let's say tomorrow your manager comes to you and says, in some situations, we need to compress data before storing it in the cloud. For example, when we're dealing with large files, perhaps images or video files, we want to compress them first. So we don't want to modify this original cloud stream class because it's going to store data exactly as it is in plain text. We also don't want to touch this class because we don't necessarily need compression when we are dealing with sensitive data. So we should create another class called compressed cloud stream. And we're going to use the same technique that we use when encrypting data. So this class should extend the cloud stream class. Here we should override or change the implementation of the write method. So we type write. Now, before writing the data to the cloud, we want to compress it. So let's imagine we have a private method here that compresses our data. Now, for simplicity, I'm going to return data.substring 0 to 5. So we're going to return the first 5 characters of this string. Now, let's compress our data and store the result in a variable called compressed, and finally pass that over here. Pretty straightforward. Now, we have a problem here. Tomorrow your manager comes to you and says, in some situations, we need to encrypt and compress data before storing it in the cloud. Our current implementation does not solve this problem. We can either encrypt data or compress it. So we have to create a new class that is the combination of these two. called compressed and encrypted cloud stream. Wow, look at that name. It's so long. So this should also extend our cloud stream. Now, I don't want to spend time implementing this class. You got the idea. The problem we are facing is that for every feature we're adding, we need to create various classes that combine these features. Here we're dealing with only 2 features, but in a more complex system with, let's say, 5 features, we have to create so many classes that would combine these features. That is not a maintainable approach. This is the problem that we can solve using the decorator pattern. With the decorator pattern, we can add additional behavior to an object. So in our main method, we can create a regular cloud stream object, and then we can decorate it with additional behavior. For example, we can add compression to it, or compression and encryption, or perhaps encryption and logging. We can decorate this object with different behaviors. We're going to look at how that works in the next video.